today's lesson, we are going to look at drawing a orthographic projection. This will be a continuation from our last lesson, which we did the first step in the orthographic projection drawing, which is the front view projection. And while I am going to show you the process from the very beginning, if you don't remember everything about that lesson, I do suggest you go back and rewatch that lesson, as I'm not going to go over the steps in quite as much detail when we're making these projection drawings. I assume that you have a basic understanding of how to make a simple projection, at least from the front view. We'll now be moving forward and working on the side and top view. When we combine these three views into a multi-view drawing, this is what is commonly referred to as a orthographic projection. It's a common method of representing a three-dimensional object using three two-dimensional projection drawings, usually the front, the side, and the top. Now, these drawings can be made by drawing from life, such as from a three-dimensional model, or you can use your imagination and just draw directly out of your head. Today we are going to be using a isometric drawing, just as we did in our last lesson, which for now I'll tape right here in the top right quadrant. This will later be removed, but you can work directly off your computer screen with the image I upload for you. Simple orthographic projection drawings such as this are commonly used to machine brackets for certain industrial purposes or simple parts, but with a bit more practice and a bit of imagination, you can make something more complicated, such as a design for an automotive company. Such a step would be an integral part in the design process. And it's also used in things like game design or 3D animation for designing characters as templates when doing 3D rendering. So just to get caught back up to where we were last week, we did the first view, which is the front view projection. We know that the isometric graph paper is 1/4 inch, which corresponds to the 1/4 inch graph paper that we're using to draw our 2D projections. So we can just count the cells and quickly block in with some construction lines the shapes we need in the center of this drawing plane. And then we'll go back over with some visible lines here to the outside edges of the object. And we'll include any necessary detail with some hidden lines for the back, which will be shown in another view in more detail, such as this side view projection, which I'm about to begin. Now, I'm going to choose where to draw this side view projection. I'm going to pick a line that's close to the middle of this quadrant here, much like we did when we started the front view projection, but I'm not going to do it for the y-axis of the drawing, the up-down dimensions. I'm going to use something called projector lines to determine the height of each section of the shape which I'm drawing, as opposed to duplicating the steps I took in creating my front view projection by remeasuring and recounting the number of cells in each shape. This might not seem like a huge advantage on a simple drawing such as this, but when drawings become more and more complex, this method is a necessary step for ensuring that your two view projections correlate perfectly to one another and line up perfectly, because these are supposed to be the same object. If you draw your side view projection with things that don't line up perfectly correct, you're not drawing the same object anymore. You're drawing two different objects. So here we have these projection lines which give us the height measurement for all the important points in our drawing. It's almost as if we could slide that over and use it as a template. So now I just need to figure out how wide any given point on my drawing needs to be. So I'm going to start with the base of the object as the widest point, being 5 cells wide. So I will count over 2 cells and draw a construction line for the left side of the object. That's that tall front corner on our isometric drawing. So I'm going to draw that right here with a light construction line. And then I'm going to need to make a measurement to see how wide the corresponding right side of that section is. So that's 3 wide, so I'll count 3 cells over, which puts me 1 cell past the midpoint. There's my right side of that section, and now there's the 2 cell tall section and 2 cell wide section. So I'll do a short construction line there. And this is that section of the drawing that we drew in hidden lines on the front view projection, which we can now draw with object lines on the side view projections. This is an important distinction, which we'll learn about more when we talk about dimensioning. If you remember our lesson on the alphabet of lines, I said we can't dimension to hidden lines. So when I want to add dimensions to this drawing, I would need to do so in a view which shows the height of that section using visible lines. And once I have everything blocked in using construction lines, it's very easy to go in and trace over those construction lines with the corresponding visible lines to create my front view projection. It should be easy to see this section that I'm blocking in using visible lines. Once I've finished blocking this section using the visible lines, I'm going to look to see where I may need to include detail not visible from this perspective with hidden lines, just as I did in the front view projection. But first, I really need to finish blocking this in using the visible lines to create my completed side view projection of the hard edges of the object. Okay, now I want to look at my drawing and say what important information about this object is not visible from this view. And it's pretty easy to see that this back edge here is an important characteristic of the drawing that I can't see from this view. So I'm just going to draw that in exactly where that corner would be using some hidden lines. Those are those dashed lines we use in the front view projection. We'll use those again here to show that the height of this object changes, and I just want to erase those construction lines that's still visible between my hidden line. I probably should have erased the construction lines first before drawing that hidden line. It makes things a lot easier. So here I have my completed side view projection. It shows the important information I can't see with the hidden lines, and it's perfectly lined up to my front view projection. Now I need to do my top view projection. And again, we can use some information from our front view projection drawing to help us line up our proportions for our top view, just by extending some of these construction lines as projection lines. We can go ahead and perfectly line up the sections of this object for our third view, which is our top view. So any detail I have in this front view projection, including the hidden line detail, I'm just going to project that right up to our top view. Now, how do I get the information from my side view projection over to my top view? Well, there's a way to reflect those details over. And to do that, we need to use a 45-degree angle. Now, normally we could use this triangle here, which is a 45-degree triangle to do so. But you guys are going to have to use your graph paper to make your 45-degree angle. Now, I want to make sure that I draw this use over the top of the object which I'm reflecting it over. You'll see why in a moment. So I'm just going to make a nice light line through the corner of each cell of my graph paper and make sure that that line extends far enough to completely cover the object which I'm reflecting. Okay, so once I have that drawn in, I'm going to go ahead and extend my projection lines up from the important detail edges of my object from the side view. And they should meet at diagonal 45-degree line exactly at the corners of my cells. If they don't, I didn't do it correctly. So make sure your line was drawn straight and your 45-degree was drawn correctly. And go ahead and draw those projection lines in for the important edges of the object from the side view. Once those are drawn in, you can then draw lines perfectly perpendicular across that 45-degree, and that will translate them exactly to the right position on our top view projection in the top left quadrant. Now, once I have all my projection lines drawn in, I have all the information I need to block in my overhead perspective using object lines. The difficulty is knowing which edges need to be blocked in and which ones are just overextensions. This can be pretty easily figured out if you just look and see what points correspond to which intersections for your corners of each object, because any point on the object will line up to a corresponding edge. So if you want to, you can just follow the projection line from any corner of your object to see where the lines intersect to find that corner on the overhead view. Again, it's very easy to see this if you have your isometric object to reference. On a more complex drawing, it's helpful to know that if you need to go searching for corners or edges, you can do so using this method. But you will all be able to very quickly see the outline for the top view projection just by referencing the isometric drawing. You can see the three sections of the top there are variously displayed in object lines. There's no information that's not visible from this perspective that we would need to show in hidden lines. So that would be the completed version of our top view projection. And with these three views, you have a completed orthographic projection. All that's left to do is to go in and get rid of those construction lines. So I hope you enjoy this video lesson on how to complete an orthographic projection. If this moved a bit quickly for you, remember there is a lesson dedicated just to how to complete a simple front view projection, and that information is relevant for completing the other views as well. As we move on to more complicated drawings such as radial forms like rounded corners, cylinders, circles, or sloped edges and planes, the same principles that we learned in this drawing will be applied to those new drawing techniques. That's going to do it for this drawing. See you on the next one.